Welcome everybody to this presentation on the chemistry of foods. This presentation is divided into two parts, part 1 and part 2. First of all, what is a food? Any substance that can be metabolized by the body to give energy and build tissues is called food. Why do we need foods? Because we have to maintain a healthy body and also for its growth. Therefore, the food should be what the body needs, and what the body needs depends on what the body is made up of. So we should understand what the body is made up of. On average, about 60% of water by weight, hence oxygen and hydrogen are the major components. Carbon and nitrogen are also present in muscles and fat. Carbon, oxygen, nitrogen, and hydrogen make up about 95% of our weight. A number of other metal ions like phosphorus, calcium, sodium, potassium, sulfur, chlorine, iron, silicon, zinc, rubidium, and so on are also present in the body. And all of them have an important role to play in the body. They may be present in very, very small amount, but they are very, very essential for the body. The 10 most abundant elements in our body in terms of weight percentage are oxygen, about 65%, carbon 18, hydrogen 10, nitrogen 3. The others are calcium, phosphorus, potassium, sulfur, chlorine, and sodium. If we just take up oxygen, carbon, hydrogen, and nitrogen, this makes up almost 96% of our body weight. That means only 4% of the body weight consists of other elements, including important ones like calcium and phosphorus, which are part of calcium phosphate in bones and teeth. How are these elements present in the body? Many are present as the corresponding ions. For example, chlorine and iodine are present as chloride and iodide ion. Sodium and potassium are present as corresponding sodium and potassium cation, and so is calcium cation. Many elements are present as ions in combination with others, such as phosphorus is present in phosphate, often in calcium phosphate, which is present in teeth and bones. Selenium is present in selenoproteins and acts as a peroxide squenger. Manganese and molybdenum are present in metalloenzymes such as pyruvate carboxylase and xanthine oxidase. Iron, we know, is present in hemoglobin, and so on. Therefore, the food must contain all these essential components, and these essential components are called as nutrients. So the nutrients are chemical substances in food which provide energy and materials required by the body, that is, for the maintenance of the body and for its growth. They are needed by the body for good health, keeping good health. And these nutrients are divided into 6 parts, namely the carbohydrates, fats and oils, proteins, vitamins, minerals, water. Some people also write roughage as a nutrient. Though roughage is very, very essential for the body, it does not really provide a nutrient, but it's important as a material in the body, as we shall see later how. These nutrients can be divided into macronutrients and micronutrients. Macronutrients are the ones which are required in large amount and hence are called macronutrients, like carbohydrates, proteins, and fats. Micronutrients are required in much smaller amounts, and that's why these are called as micronutrients. And micronutrients contain all the minerals, metal ions, and all the vitamins. Now, all these may be required in much smaller amounts, but they are very, very useful. The requirement of macro and micronutrients depends on variables like gender, age, health condition, pregnancy, activity level, etc. The foods that we eat are generally classified into three: classification by origin, that is foods of animal origin and foods of vegetable origin; classification by composition, that is proteins, fats, carbohydrates, minerals, and vitamins; and classification by predominant functions, divided into three, called bodybuilding foods, which consist of meat, milk, poultry, fish, eggs, pulses, etc.; energy giving foods, which consist of cereals, sugar, fats, oils, etc.; protective foods, vegetable foods, milk, etc. So we will talk of in this part mainly on macronutrients. So the first macronutrient, the one which is required in the highest amount, is nothing but carbohydrates. Carbohydrates are what we call the sugars, and these are classified as monosaccharides, disaccharides, oligosaccharides, and polysaccharides. Monosaccharides, generally we are well familiar with glucose, fructose, and galactose. And disaccharides, we are most famous with the sucrose, that is our table sugar, and lactose and maltose. Oligosaccharides contains a number of oligosaccharides are there, but two of them, like raffinose and stachyose, are found in dried beans. And then the polysaccharides, which consist of starch, fiber, and glycogen. Now, there are different types of polysaccharides, and we'll look at some of these. Starch, which is part of our food, is mainly made up of two components, amylose and amylopectin. And fiber, that is what we call dietary fiber or roughage. And glycogen, a form of glucose, which is stored in the body as glycogen. The other forms are dextrins. Dextrin is nothing but partially broken starch molecules, and therefore they have less thickening power than starch. And of course, fiber, that is plant fiber component, as I said, also called dietary fiber, sometimes called as bulk cellulose, or also has hemicellulose. Then there are beta glucans, another form polymer of glucose found in oats and barley. Pectin substances, these are again used in forming gels and jellies. The structures are shown here. The glucose, which is 6-membered ring, fructose, a 5-membered ring. The disaccharide means made up of two carbohydrate molecules. So the two carbohydrate molecules are joined together. See. And then we have starch and cellulose fiber. We can see that both of these are polymers of glucose. The starch is a polymer linked through 1,4 position, but it has a alpha linkage, whereas the fiber, that is cellulose, has beta linkage. Our body consists of amylase enzyme, which can hydrolyze starch, but we do not have cellulase in our body to hydrolyze fiber. And this fiber acts as a roughage and is used to excrete waste products for body and to maintain the bowel regularity. So cellulose is and starch, they are both monomers, polymers of glucose, but one is alpha polymer and the other is a beta polymer. Question is, what should we be eating? It is simple carbohydrates versus complex carbohydrates. The carbohydrates consist of fiber, starch, and sugar. These are broadly classified as simple and complex carbohydrates, are simple carbs and complex carbs, abbreviated as carbs for carbohydrates. Fiber and starch are complex carbs, are complex carbohydrates, while sugar are glucose, are fructose, are lactose. These are called as simple carbohydrates or simple carbs. The nutrient quality depends on how much of each of these is present in a food. While some of the simple carbohydrates occur naturally in milk, most of the simple carbohydrates are added to foods. And common simple carbohydrates added to foods include the raw sugar, most common, then the brown sugar, and then there's corn syrup or HFSC. It is called high fructose corn syrup. In fact, this is now available in plenty amount. It is even cheaper than sugar, and many of the concentrates that we buy actually contain HFSC. In fact, the sweetness level of HFSC is more than sucrose. And also glucose and fructose are added to foods. The most common refined sources of simple carbohydrates that we consume should be avoided, and one should look for alternatives to satisfy for those sweet cravings. And these include the soda and cold drinks, the pie, the cookies, cereals, juices, which may be rich in simple carbohydrates, and it's not advisable to take too much of them. The more complex, the better. The complex carbohydrates pack in more nutrients than simple carbohydrates because they are higher in fiber and digest more slowly. This also makes them more filling, which means they are a good option for weight control. They're also ideal for people with type 2 diabetes because they help manage post-meal blood sugar spikes. The raw sugar or simple carbohydrates post-meal blood sugar spikes are very high, but with complex carbohydrates, these can be managed. Fiber is essentially important because it promotes bowel regularity and helps to control cholesterol. In other words, LDL, or what we call bad cholesterol, low density cholesterol, is not good. So more fiber helps in forming the LDL. Complex carbohydrates, therefore, are the key to long-term health as they make it easier to maintain weight. The main sources of dietary fiber include fruits, vegetables, nuts, beans, whole grains, etc. Certain foods are considered more starchy than fibrous, such as potatoes. They do have fiber, but they are starchy. Other high starch foods include the whole wheat bread. This is what should be. In fact, if one has to have bread, one should prefer a whole wheat bread compared to a normal bread. Cereals, corn, oats, peas, rice, etc. So the more complex, the better. It has been reported in a paper. It says that sugar beats stress better than sweeteners. So those who take artificial sweeteners, it is said that sugar is better and it can help fight the stress. Well, one does not have to go for isolated research papers because they may have not taken sufficient data to come to the conclusion. The metabolism of glucose. Glucose undergoes anabolism, catabolism to pyruvic acid under aerobic condition and lactic acid under anaerobic conditions. And glucose in the body is regulated through glycogen in the body. There's only a limited amount of glycogen which can be stored. Whenever there's a deficiency of glucose in the body, the glycogen is converted into glucose 6-phosphate. And if the glycogen level falls beyond a the fixed limit, then the fats get converted into glucose and stored as glycogens. However, 90% of the metabolism of glucose gives rise to pyruvic acid and carbon dioxide. And the pyruvic acid, once formed, is converted into acetyl-CoA and enters the citric acid cycle, as shown in the next. Here, as you can see, the glucose is converted to glucose 6-phosphate, which can undergo catabolism to pyruvate and then to acetyl-CoA, which enters into the citric acid cycle, or it can undergo pentose phosphate pathway to give pentose phosphate, which is the precursor for nucleotides, and also for various other compounds. The glucose 6-phosphate undergoes glycogenesis and is stored as glycogen. And whenever the glucose level falls, as I said earlier, the glycogen is converted into glucose by glycogenolysis. Then we come to fats and oils, another important macronutrient, and this is the one which is most talked about. In fact, one goes, between fats and oils, if one goes by the definition of this, the definition is very loose and not very convincing. As per the definition, anything which is solid at room temperature is called a fat, and anything which is liquid at room temperature is called oil. The issue comes up with the coconut oil because in the northern region, in winter it becomes a solid, in summer it becomes oil. So whether it should be classified as a fat or oil, it's because of the definition that I said that. However, fats and oils are very important for the body. They have very important roles in the body. And one of the main roles in the body is protection. This includes insulation to keep the body temperature and cushioning to protect the body organs. They also promote growth and development as well as maintaining cell membranes, because cell membranes also contain cholesterol and other components. Fats, in addition, play a vital role in the digestion of vitamins because they are vitamins which are fat soluble, like A, D, E, and K, and they need fat in order to be absorbed in the body and for their transportation. In fact, fat is the most concentrated source of energy in the body. Unlike glycogen, where there is a limit in the body to be stored, excess gets converted into fats. There is no limit on the amount of fat that can be stored in the body. Most of it is no doubt stored in the adipose tissues. So excess sugar also gets converted into fat via coacetyl A by anabolism and stored in the adipose tissues. Because there's no limit, I mean, that one has to watch, that we should rather be controlling ourselves. What are fats and oils? Chemically, they're made up of glycerol and 3 fatty acids, 3 moles. In other words, they are triester of glycerol. And the 3 different acids attached to glycerol can be same or different. And all 2 could be same, 1 could be different, or all 3 could be different. And the oils that we buy contain a mixtures of such glycerol triesters. They are not pure oil of containing one set of molecules. And these oils and fats are categorized as saturated fats and unsaturated fats. The saturated ones, which have no double bonds in the carbon atoms, whereas unsaturated fats have double bonds between some of the carbon atoms. The different kinds of fatty acids present in these fats and oils are the most common are palmitic acid, C16 onwards, palmitic acid, stearic acid, oleic acid, linoleic, linolenic, and arachidonic. So we have a C16, C20, and in between we have 4 C18, saturated, monounsaturated, diunsaturated, and triunsaturated. All the double bonds in these fatty acids are in cis form. They are cis double bonds. And more the number of double bonds in a triglyceride, lower will be its melting point. In fact, the double bonds are less stable to oxygen, and they get oxidized fatty acids. And therefore, in order to prevent oxidation, antioxidants are added to oils. Fats have generally saturated acids present in them. It's nowadays there's a lot of discussion on omega-3 fatty acids and said to be useful for the body. Let's look at other fats. These include phospholipids. The phospholipids contain, again, are derivatives of glycerol, contain two fatty acid chains, long chains, and the terminal carbon contains a phosphate group, which may be a choline, and this R may vary to give different phosphate derivatives. For example, the cell membranes are composed of mainly phosphatidylcholine, phosphoric acid, and cholesterol. In fact, phospholipids are bipolar, and they have a polar head group and a hydrophobic chain. The cells, as we know, are bilayers, and therefore there's a aqueous layer inside and aqueous layer outside, whereas in between there's a hydrophobic region because of the hydrophobic chains of these phospholipids. The other fats are sterols, like cholesterol. Composition of fatty acids in selected oils, as you can see here. Sunflower oil has the highest percentage of polyunsaturated fatty acid, whereas olive oil has the highest percentage of monounsaturated acids. There's a big discussion between whether polyunsaturated fatty acids are good or monounsaturated fatty acids are good. But at the same time, one should see that olive oil also has a 14% saturated fat, whereas sunflower oil has only 10% saturated fat. Saffron oil has the least amount of saturated fat, and whereas saffron oil has also very high percentage of monounsaturated fat. And then coconut oil and mustard oil I like to focus on in the palm oil. Coconut oil, as you said, it is solid in winter in the northern India and liquid in summer. Why it is so? In fact, unlike all other natural acids, the coconut oil is the one which also contains fatty acid, which is C14, that is myristic acid, and it is 47% of lauric acid, which is C12. It also has 6% of capric acid and 6% of caprylic acid, C8. And it is these smaller chains which make the molecular weight lower are also responsible for its very low melting point. And one can, nowadays people say coconut oil is good. Well, in one way we can say yes, it may be advantageous, because lesser the number of carbons, lesser the number of coacetyl A will be generated, and hence the lesser the amount of energy that will be generated. Then coming to mustard oil, yes, it contains arachidic acid, it contains folic acid, it contains uricic acid, and 12 to 6% C22 acid, and it has linolenic acid 7 to 10%. Why I'm focusing on linolenic acid 7 to 10%? Because linolenic acid is omega or omega-3 fatty acid. Nowadays, as I said earlier, that we are talking of omega-3 fatty acids are good, then I would think that yes, mustard oil is the richest source of omega-3 fatty acid. The other oil which we use commonly, palm oil, also has 36% of monounsaturated and also linoleic acid, the unsaturated acid. So which oil one should be consuming is one's own choice, but one should not go by cost. But nowadays it's recommended that one should keep on changing oils and not stick to one kind of oil. Virgin coconut oil, nowadays a lot of interest in that. Trans fats. Trans fats are associated with risk of heart disease and diabetes. What are trans fats? The industrial trans fats are produced during partial hydrogenation when liquid vegetable oil turns solid. The hydrogenated oil called vanaspati in India is used as a cheap alternative to ghee in the industrial production of sweets, bakery items, biscuit, food, etc. You see, we have discussed that the oils contain cis double bonds. When we do the saturation or when we do partial hydrogenation, some of these double bonds get converted to trans double bonds and they become trans fats. Not only this, repeated heating of oil also converts some of these cis acids into trans fatty acids, and these are not said to be good for health. In fact, the Indian regulation, FSI, has set the level of trans fatty acids at 10% or less, whereas the WHO guidelines say no more than 1% of our daily energy requirement should be coming from trans fatty acid. Red flags like obesity, heart disease, diabetes, infertility, depression, and so on have been associated with trans fats. So the foods like low-fat butter, margarine, rusk, popcorn, instant soups, Mahakosh refined oil. I mean, some of these oils may also contain trans fats, and one should be careful about the amount of trans fats. Fats are metabolized into glycerol and fatty acids by lipases and phospholipids. And fatty acids are then broken down by beta oxidation pathway into acetyl-CoA, which again enters the citric acid cycle. And then coming to the third macro component, the proteins. Proteins are large molecules of amino acids joined together with a peptide linkage. We already have studied about primary, secondary, tertiary, and quaternary structures of proteins. The monomer is nothing but the alpha amino acid. There's a variation possible in R. It can be acidic, it can be basic, it can have a hydroxyl group, it can have a thiol group, it can have a basic group, and so on. And these different side chains make the proteins take up different structures. And therefore, we know that we have variety of enzymes. And variety of enzymes have different structures only because of variation in the R groups in a molecule. The proteins are made up of about 22 amino acids. Humans manufacture about 18. The others are called as essential amino acids like leucine, isoleucine, lysine, phenylalanine, threonine, tryptophan, valine, histidine, and so on. Proteins are very crucial in the body for bodybuilding, for its maintenance, and also for repairing body tissues. The diverse roles of proteins, most important roles of proteins are enzymes, because all the metabolic processes in the body are regulated by enzymes, and they are all proteins. Then hormones, which are responsible for communication in the body. Not that all hormones are proteins, but majority of hormones are protein, especially all the ones which are released from hypothalamus and go to pituitary are small proteins. They are also regulators, they are molecular transports, and we know antibodies are also nothing but proteins. They are building tissue for the muscles and energy. So all enzymes and the hormones, they perform vital function, they're all proteins, and they also aid in the immune process. Eating different types of protein can ensure sufficient intake of essential amino acids which are needed by the body. Two amino acids, tryptophan and tyrosine, are precursors to serotonin and L-dopamine series of neurotransmitters. So this is about the three macronutrients. And now if we look at their energy, whereas carbohydrates provide 4 calories per gram, proteins also provide 4 calories per gram, fats provide 9 calories per gram. That is 2.25 times more. And as I said earlier also, that there's no limit on fat which can be stored in the body, but there's a limit on the carbohydrate which can be stored in the body. It is recommended that 50 to 55% of energy must come from carbohydrates, about 30% from fats, and 15% from proteins. We should also know that hormones are also water soluble and fat soluble. So fats have also a role there. They may be helping in the transportation. And lastly, coming to energy density, here are shown two types of breakfast. Both provide 500 calories, whereas the weight here, amount of weight that we go to eat is 450 gram. Here the weight of the two donuts is only 144 gram. So the energy density is 3.5. Here the energy density is 1.1. We should prefer low energy density foods and avoid high energy density foods. Well, I mean, once in a while it may be fine, but it should not become a practice. With this, I think we come to the end of this lecture. And if you have any questions, you can call me at 98106-511-42 or email me at jmkhurana1@yahoo.co.in. Thank you.